In the last module, I went over how to write an equilibrium expression for a given reaction. In this video, I'm going to be going over how to write an equilibrium expression for an acid-base type reaction. So if we have an acid HA and it is reacting with water, my first suggestion would be to draw a beaker to see what we have in our reaction. It will make it much easier to decide what our products will be. So we have a beaker. It is filled with water. So what we can say is that H2O is our solvent. So we will denote H2O as a liquid in our reaction. HA, and any time you are putting an acid into water, you are going to denote that acid as an aqueous species. So now that we have set up our reaction, what is going to happen when we put HA into our water? Well, the lone pairs on the oxygen of our water can serve as a base. So once you have picked your acid, by default, our other species will be a base. So this lone pair will come over and take this hydrogen away from the acid, and the pair of electrons will go onto A. So we will be left over with A minus aqueous because it is still dissolved in the water. This is because the HA, it lost its hydrogen, and that pair of electrons is now sitting on top of the A with a minus charge, and H2O now is H3O plus aqueous. So from our reaction, we can see that an acid reacted with a base, and now A minus is our conjugate base, and H3O plus is our conjugate acid. Remember, the conjugate base is what is left over from that acid giving away its hydrogen, and the conjugate acid is now the base with a hydrogen added. So as we saw in the equilibrium module, we are going to write an equilibrium expression for this reaction. It is still K. And K is still equal to products over reactants. In this case, we need to be careful. We're going to exclude water from this K expression. It is a liquid. It is not going to be a part of this K expression. So our products are A minus and H3O plus, A minus H3O plus over HA. So we have now written our equilibrium expression for our acid-base reaction. This K has a special name. It is called Ka. It is still products over reactants. It is still simply a ratio of our products concentration over our reactants concentration at equilibrium. However, it is given the special name Ka, A for acid, to tell us that this specific equilibrium constant is for an acid reacting with water to form its conjugate base and hydronium. So you will see acids have a Ka value associated with them, and we will see in the upcoming videos how a certain Ka will lead us to attack a problem differently from other acids with other Ka values that might be bigger or smaller.